For this problem, we have V1, V2, V3, and V4 we have to solve for. So first thing we see is there's two potential supernodes here, because as you see, if there's, let's say, current moving in these two directions, let's call it I1 and I2, it'll be difficult to actually solve for I1 and I2 because we don't have any resistors to help us solve it. So what we're going to do is we're going to do a supernode. So let's write the equation for this 20 volt source. So we see if, let's say, the current is moving in this direction, it leaves through the positive terminal. It leaves through here. So it'll be V2 plus 20 volts equals V1. Okay, it increases by 20 volts. And the same thing here for this dependent voltage source. As current moves in this direction, it increases by 3 Vx volts. So it goes from V4 plus 3 Vx equals V3. Okay, now we're going to treat this as one entire supernode, and same with this as one entire supernode. So anything entering or leaving the current from this section is equal to anything entering or leaving the current from this section as well. Okay, sorry, I mean anything entering or leaving the node from this section is equal to anything that's entering or leaving the node from this section as well, and same with this as well. So first thing, we're going to write directions of current. So let's call this I1. Let's call this I2. Let's call this I3, I4, and I5. And remember, this is the ground voltage. So it's 0 volts down there. So let's write an equation for node V1 and V2. So for this portion, we see I1, I2, and I3 are leaving it. So it'll be I1 plus I2 plus I3. And we see the 10 amp source is entering it. So it'll be equal to 10 amps. Now let's write the equation for this one, node 43 and 444. Sorry, node V3 and V4. So it'll be node V3 and V4. We see the 3 amp, the I3, I2 are entering it. And we see I4 and I5 are leaving it. So we now got our two equations down. Let's find the I values so we can substitute them in. So let's find I1. We see it goes from V1 to 0. So V1 over 2. I2, we see it goes from V1 to V4 over the 3 ohm resistor. So it'll be V1 minus V4 over 3 ohms. Now for I3, we see it goes from the V2 to V3 all over the 6 ohm resistor. So B equal to V2 minus V3 over 6. I4, you see it goes from V3 to 0 all over the 4 ohm resistor. So it'll be V3 over 4. And for I5, it goes from V4 to 0 over the 1 ohm resistor. So it'll be just V4 over 1. Now we can start plugging all these in. So I1, it's V1 over 2 plus V1 minus V4 over 3 plus V2 minus V3 over 6 equals 10. And then for node 3 and 4, it'll be V1 minus V4 over 3 plus V2 minus V3 over 6 plus equals V3 over 4 plus V4 over 1. Now we have two equations finished, but we have but we will need 2 more because we have 4 unknowns currently. So that's why now we can use these ones. So V2 plus 20 equals V1, that's another equation. And then V4 plus 3Vx equals V3, that's another equation. But notice that if we have the Vx, then we would need 5 equations. But we can try and get rid of that Vx, because notice Vx is this portion, and Vx will equal to the current that's passing through this resistor times the resistor value. So it'll be I2 times 3 ohms. And what was I2? I2 was V1 minus V4 all over 3. So it'll be V1 minus V4 all over 3 times 3 ohms. And these 3's cancel out. So Vx is just V1 minus V4. And then, so we'll just plug that into here. And we get V4 plus 3, V1 minus V4 equals 3. Okay. Now we have all these equations set up. So let's try and simplify it more, and then we can go over what we should do next. So let's first work with the first one. V1 over 2 plus V1 over 3, that will be equal to 0.8333 V1. Now we have V2 over 6, which is 0.1667 V2. Now we have minus V3 over 6, so it's minus 0.1667 V3. And then we have minus V4 over 3, so it's just minus 0.333 V4, and it's equal to 10. Okay, so that's our first equation done. Now our second equation. So it's V1 over 3, and that's the only V1 we have. So it'll be 0.333 V1. Now for V2, we see there's V2 over 6. So it'll be plus 0.1667 V2. Now we see there's minus V3 over 6, and there's a V3 over 4 on the other side. So if we bring this V3 over 4 to the other side, it'll be minus V3 over 4. So it's minus V3 over 6 minus V3 over 4, which is 0.4167 V3. Now we have minus V3 minus V4 over 3 on the left side, and we have V4 on the other side. So let's bring this V4 to the other side. So we would have minus V4 over 3 minus V4, and that gives us minus 1.333 V4. And since we brought both of these two to the other side, this will be just 0. So it's equal to 0. Now for this one, let's bring the V1 to the other side and the 20 to the other side. So it'll be V minus V1 plus V2 equals minus 20. Now for the last one, let's bring it down here. So it's V4 plus 3V1 minus 3V4 equals, I realized I made a mistake. It's supposed to be V3 here, not 3. So yeah, my apologies. So it's just V3, because the Vx was V1 minus V4, and all of this is equal to V3, not 3. Okay. So, and this is equal to V3. We see there's two like terms here. V4 minus 3V4, so that's minus 2V4. And we can bring this to the other side, so it'll be 3V1. Sorry. Minus V1 minus V3. Wait. Hold on. Yeah, okay, sorry. 3V1 minus V3 minus 2V4 equals 0. Okay? So that's your equations all set up. Now, if we can put them through a MATLAB, and we will get the following answers. So V1 will equal to 26.7108 volts. V2 will be equal to 6.7108 volts. V3 will be 173.718 volts. And V4 will be equal to minus 46.793 volts.